Okay, so today we are starting kind of a mini unit. Technically, the stuff we're going to do today was supposed to be in Unit 4, and some of it was supposed to be in Unit 3, but we all got together and just decided to wait because there was so much that we were learning in Unit 4 that we knew that you guys would kind of be bogged down a little bit, so we wanted to kind of hold off on some of it. So we're going to call this Unit 4B because technically it's supposed to be in Unit 4, but we just kind of waited a little bit. And this is our inequality unit. So this is all about inequalities. Inequalities. So when you see that word inequalities, what does it kind of make you think of? What do you think that's the root word might be? Unequal, right? Equal is in there, but unequal. So the prefix in means not. So this means not equal. So an inequality is a whole lot like an equation, except for it's not. Because an equation, one side is always equal to the other side, but in an inequality, one side is always more than the other side or less than the other side. Okay, so it's not necessarily equal. So that's what inequalities are. And this is where you're going to get those arrows that we've been using, the less than, greater than, less than or equal to, greater than or equal to. And we've already talked about those some with domain and range. So I'm hoping you're kind of starting to get the hang of those. But if you don't know those, you have got to just memorize them. I don't know any other way to get those down except for just really practicing, using flashcards, something. You've got to know which ones are which. Okay, so to get started, there's some basic rules for inequalities. We're going to start out, this is day one, we're only going to have pretty much one, maybe two sets of notes. We'll do some review, some practice, and then we're going to have a really short test. This should be a really easy, quick unit. So we will be testing on this by next week, about this same time. So it's going to go by really fast. And then we'll get ready for Unit 5. We won't get all of Unit 5 done before Thanksgiving, but that's okay. We'll get started. So inequalities. Let's see. How about one variable inequalities? This is going to be our title for this page. One variable inequalities. That means it has one variable in there, one letter. So we've been doing equations with two variables, a y and an x. We're going to kind of revert back to Unit 2 and 3 and think about when we just had one variable and we were solving. Here's how you do this. These are the steps. Solve an inequality exactly like an equation. Except, there's always an exception to the rule, right? So the one exception, except if you multiply or divide by a negative number the inequality sign switches. So if you multiply or divide by a negative, you have to switch your little arrow. So remember, you had, this is less than, this is less than, or equal to, this one is greater than, and the last one is greater than equal to. Okay, so that's your 4. So instead of an equal sign, these will have one of these symbols. Okay, and you'll catch me, I'm really bad about calling them equations or saying the equal sign when it's really not an equation, it's an inequality. And it's really not an equal sign, it's an inequality symbol. But I'll write those down. We've already written them in a previous unit, but we'll write them down again just so that you can get used to it. One other thing that you need to know has to do with your little red square that you have. It says 1 variable inequalities in graphing. So I want you to get that one out, cut it out, and we're going to glue it down right here in the middle. So it's in red. It says 1 variable inequalities graphing. So get that glued down for me. We're going to fill it out. Okay, so this is just going to help you. Remember, it's in red. For less than or equal to, if it's color or if it's underlined, do you remember what our circles look like on our graphs? Because this is going to be the same. If it was underlined, what do you know about it? It was colored in. It was closed. So closed circle. So if you want to color that in, you can like this. And the arrow points left. For greater than or equal to, this is a closed circle. Again, looks like this. Arrow points right, obviously. And I've noticed that some of you have a really difficult time when I say which way does the arrow point. You don't know what I'm talking about. You guys, the point is this tiny part right here. That tiny part right there. If you think about shooting a bow and arrow, and I'll just draw it to the side, you don't have to draw this, but think about shooting a bow and arrow, and the arrow looks like this. If I'm shooting that arrow, it's going to go the direction that little part is pointing. That is the point of the arrow. When it lands in the ground and sticks in the ground, the point is stuck down, and this part back here is stuck up. Okay, so the point is this way. This one's pointing to the left. This one's pointing to the right. Pointing to the left, pointing to the right. So when you learn to drive, and you're in Walmart, because my biggest pet peeve on a parking lot is people who cannot read the direction of the arrows. So hopefully you know which way to go down the little parking lot lanes based on which way that arrow points. Okay? I don't want to see you driving the wrong way on the lane because of the arrow. You should know. All right, what about this one? This one doesn't have an underline, so this is an open circle. This just looks like this. Arrow points left. Greater than is also open circle, so it looks like this. And this one points right. So that's just going to help us out. I know it's maybe kind of hard for you to see. Let me zoom in a little bit. There you go. Closed circle for the first two, open circle for the last two, and then it goes left, right, based on which way the arrow points. Okay, so now we're going to do some practice. You guys have 1 through 5 on your page to cut out. So if you'll just cut out 1 through 5, you can leave them all stuck together. And you see those little number lines over to the side? Leave those there. So I don't know if this will fit. Let me see how much I can fit on mine. We may have to cut it in half. Yeah, it's not going to fit. So we're going to do 1 through 3 on this page and 4 and 5 on the next. How about that? So 1 through 3 is going to go down here at the bottom. I'm going to zoom back out so you can see where mine is. So 1 through 3 is going to be down here at the bottom, and then 4 and 5 will be on the top of the next page. There we go. Don't throw away 4 and 5. You're going to need those in just a second. Okay, so you're going to treat these exactly like an equation. So you're doing the same thing that you've been doing with your equations. So this is the little inequality symbol where the equal sign usually is. Draw a line down the middle. If if I had that as an equation, what would be the first thing I would do? I would subtract 2r from both sides, right? So I'd go minus 2r here, minus 2r there, just like I would if it was an equation. This goes away. 3r minus 2r is 1r, still plus 17. And instead of equals, I've got the greater than or equal to symbol. And this is 14. Okay, now I'm going to take this 17 to the other side by subtracting. This is taking you back to unit 2 and 3. You get r is greater than or equal to negative 3. Okay, did I multiply or divide by a negative number? No. So since I didn't multiply or divide by a negative number, my little arrow stays exactly the way it was when it started. This is my answer. And when you graph that on the number line, here's your 0 kind of in the middle. Negative 3 is going to be over here somewhere. So go ahead and just sort of label it. You don't have to draw all the little different numbers. Just sort of label it. You're going to put a circle right there above it. Is it going to be open or closed? It's going to be closed because that's underlined. So underline it. I mean, not underline. Close it, colored in. And then my arrow is going to point the same direction as that arrow. So on the number line, you're saying that any number I pick from negative 3 up will make this inequality true. It will make this side greater than or equal to this side. Any number I pick from negative 3 on. That's what you're saying. So this is your answer, and it goes with this. This is part of your answer. And on your assignment, you have that little number line thing. Okay, so number 2, same thing. Draw your line down. Okay, 9t plus 5 is less than or equal to 10t minus 3. First thing is letters to the left and in front. So I'm going to subtract 10t. Now some of you already know how to change it, but we're not changing it. I want letters to the left on these. Because if you don't have your letter on the left, your variable on the left, your arrow, your inequality symbol gets all confusing. So put your variable on the left every time. I don't care if it makes it a negative 1, like we're fixing to have to deal with it. Just do it. Okay, so 9t minus 10t is negative 1t plus 5, still less than or equal to negative 3. Now what are you going to do? You're going to subtract that 5 over. So minus 5, I don't have enough room in here. So I've got negative 1t is less than or equal to negative 8. Okay, I have a negative 1 in front of my t. I need to get rid of that. So I'm going to have to divide by a negative 1, which means I've got to follow that one weird rule of inequalities. If you multiply or divide by negative, the only exception is if that happens, your arrow has to switch places, has to switch directions. So I know I'm dividing by negative. I know my answer. My arrow's going to have to switch. Only because of that one weird rule. And I could really explain it to you all mathematically and prove it to you and stuff, but I bet you don't really care. Just trust me that that's the rule. Okay, if you want to understand why, you can ask me or your teacher later. We'll figure it out. But, and I'll kind of try to explain it to you. But just trust me on this one. If you multiply or divide by negative, turn your arrow the other direction. Okay, this becomes just t. This becomes positive 8. That's my answer. So over here, I have 0 in the middle. Positive 8's over here somewhere. Here's my circle. Do I color it in or not? Yep, color it in. And this arrow points to the right, so this arrow needs to point to the right. Because if you put your letter on the left, your arrow here is always pointing the same direction that your arrow is here. This arrow and that arrow should match. They should be pointing in the same direction. But only if you're putting your letter on the left. Because if you insist on putting your letter on the right, it's all messed up. And I'll have to pull you aside and show you how do you do that one. If you really insist on doing that, we'll talk and I'll help you figure it out. Okay, number 3. Draw your line down the inequality, the middle. What's happening to that letter, to that variable p? Yeah, it's being multiplied by -8. So to get rid of multiplied by -8, all I have to do is divide by -8. I'm dividing by what? -8. The important thing being -8. It's a negative. So what does that tell me? My arrow, my inequality symbol is going to flip and go the other direction. It's like they just flip out with every negative, okay? So this becomes P, and then my arrow switches, and -32 divided by -8 is a positive 4. So here's 0. Where's positive 4? Over here somewhere, right? Draw a circle right above the 4. Is that going to be an open circle or closed circle? Yeah, it's open. That's an open circle. And my arrow goes the same as that arrow to the left. So it's saying any number from 4 on, but don't include 4. 4 doesn't count. Anything up to 4 and below will work to make this statement true. Okay, flip the page. We got 2 more like that. So glue down number 4 and number 5 up at the top. We'll practice 2 more. I want to make sure you got this down because you're going to have all this on your homework. So glue those 2 at the top. Okay, look at number 4. I have k divided by -4 is greater than 2. So here's my variable. If I draw my line down the inequality, I almost said equal sign. If I draw my line down the inequality symbol, k is being what? It's being divided by -4. So what are you going to do to fix that? How do you unwrap that step? You multiply by -4. So we're going to do this. Multiply by -4. Multiply by -4. So what does that mean? The one exception to the rule is if you multiply or divide by -4, or not -4, negative anything. If you multiply or divide by negative, what happens to your inequality symbol? It changes directions. So this time, I get k here, but instead of being greater than, now suddenly it's less than. And 2 times -4 is -8. That's your answer. Here's 0. -8 is going to be over here somewhere. Is that going to be an open circle or closed circle? It's open. You're right. And then my arrow up here for my line graph is going to go to the left just like my arrow right here is. So draw your line graph. It's just like a number line, all you're doing. You're graphing it on the number line, showing us what the answer is. Okay, last one like this. What's happening to x right there? Multiplied by -3. So we're going to divide by -3. Yes, your answer is 5. But what do you know you have to do? Because this is an inequality, this isn't an equation. So it's a little different. It's an inequality. You're going to get x, that has to switch, becomes greater than +5. Here's 0, +5's over here somewhere. Open circle, points to the right. Okay, those are all single variable or one variable inequalities. You're just solving them exactly like you would have an equation. But if it was an equation, instead of having a circle with a line going somewhere, it would just be a dot on that number. Because before, if your answer was x equals 5, then 5 is the only dot you have. That's it. But since it's anything greater than 5, it doesn't include 5, but it's everything above that. 5.1, 5.2, 6, 7, 8, 9, 10, anything greater than 5. Okay, that's what you're saying. If you pick a number greater than 5, and plug it into this, it will make this less than that. It will work every time. Okay, So any questions on single variables or one variable inequalities? Because we're going to switch gears now to two variable inequalities. So right here, let's do a new title. Two variable. These are also called linear inequalities. Two variable or linear inequalities. And we've been doing these with equations because a linear equation makes a line on the graph. So like maybe that format we had that whole warm-up of y equals mx plus b. Okay, where m is the slope, b is the y-intercept. So we've had all of that. All right, so that's linear inequalities. So I want to, this is the same rules apply. What you're trying to do, let me write this first. So put it in y equals mx plus b form. Except for instead of an equal sign, you're going to have an inequality symbol there. Okay? And graph. Because your answer to these is the graph. You don't have like an x equals 5 type of answer. Your answer to these is going to be your graph, your picture of the graph. So what I want you to do is on linear inequalities graphing, we're going to glue this down. I'm trying to figure out because I don't have to glue all of these graphs by themselves. Okay, here's what we'll do. So glue this down. Let's get this answered first. So when you graph on linear inequalities, this is kind of fun to me because we get to color, and I've always loved coloring. So I kind of like this, and if you've got a couple of highlighters, or just one, you don't have to have any, or a crayon, or I don't know. You don't want to use like a dark marker, but a lighter colored marker would be great. Would help you out. So here's how linear inequalities work out. You switch it to y equals mx plus b. We know m is good, slope. B is the y-intercept. So you're going to graph it just like you always graphed it before. You put the y-intercept on there, and then you count the slope up and over, and you put your dots. Okay, if your inequality symbol, which one is this? Less than or equal to. Yes, this is less than or equal to. So if you want to write that over here, less than or equal to, write it beside it. For that one, because it's got the line underneath it, it is a, whoops, I almost didn't write it. It's a solid line. That's the word solid, S-O-L-I-D. Sorry, my handwriting's bad. It's a solid line. Since it's less than, you shade below the line. Okay, I'll show you this in just a minute. We're just going to write it down for right now, so don't panic. For the next one, this is greater than or equal to. This is also equal to, so this is solid again, solid line. It's greater than, so you're shading above. This one's just plain less than. Just plain less than. That's going to be a dotted line. So you know how on our other ones, it was an open circle? Well, you can't make an open circle on a line. Like you don't want to make a line full of a bunch of open circles. That would be a mess. So we're just going to make a dashed or a dotted line. So a dotted line, less than is below. And then this one's greater than. This is dotted. It doesn't include the line, but everything above it. Shade above. Okay, so here's what I think I'm going to try to do. Let me see if this works. I think we're going to cut out two of these together, two of these little graphs, because you have all these graphs. We're going to do this, and I'm going to write on this side for this one and this side for this one. Does that make sense? I don't know if that's enough room. Let's just do 1. I'm worried that that's not enough room. So we're just going to do 1. We're just going to do 1 graph down here, and then we'll use the other ones for the next page. So 1 graph here. We'll just write beside it. So glue it down. So for example, this is our first example. Find my examples here real quick. We're going to start off real easy, and then we'll work our way to a little more complicated. So if I have y, almost said equals, y is less than or equal to 2x plus 3. Y is less than or equal to 2x plus 3. Is it in y equals mx plus b form? Is the y already all by itself, is what I'm asking. Yes, it's already by itself. All this other stuff is over here. So if that's the case, can you tell me what the m number is and what the b number is? Okay, m is 2, or 2 over 1. Good, and b is 3. Okay, so go to the y and put a dot on the 3. Hold on just a second. Okay, so go to the 3. 1, 2, 3. Put a dot. Don't connect your dots yet. Go up 2 over 1, put another dot. Up 2 over 1, put another dot. Up 2 over 1, put another dot. Okay. So here's my question. What kind of line will this be? Dotted or solid? Solid, because it's underlined. Solid line. So I know I can go ahead and draw the solid line like this. See, the biggest mistake I make on this is I draw the solid line and it's supposed to be dotted, so I have to go and like erase in between or something. Solid line, and it's less than, so we're going to shade below. So everything, all of this is included. What that means is if I pick any point on the line, because it's solid, or in this yellow area, I can plug that point in here and it makes that true. So I kind of like the color. So get yours shaded in. Okay, so I need you to cut out, I think we could do 3, maybe 4 down the side of the next page. We'll see. Okay, let's see. So I've got the one that I had a second ago. I believe that. I wonder if we can get all of, at least 4 of them. I don't know that we can get all of them, but. Oh yeah, we can maybe get them. 1, 2, 3. You think we can get those other 2 on there? Nope. So let's try to do 4 down this page, and we'll do the last one on the last page. Darn it. Okay, so there's 2. There's 2. Okay, so on the next one, let's do, this is number 2. What if I have, let's find the thing I'm supposed to use. What if I had 4y is greater than negative 2x plus 8. 4y is greater than negative 2x plus 8. Okay, so we have to get y all by itself. What is the one thing that's in our way right now? What's the one thing that's stuck with that y? The 4. So to get rid of that 4, it's multiplied to the y. You've got to divide. Here's the deal. Dividing here, but you have to divide here and here, or you didn't do it right. So you have to divide every single thing. Don't leave anybody out. Okay, so that becomes y is greater than negative 2 over 4 reduces to negative 1/2 x. 8 over 4 reduces to 2. Did I divide by negative? No. So I don't need to switch my arrow at all, since I didn't divide by negative. So I can say m is negative 1/2. B is 2. Is this going to be a dotted or a solid line? That's what tells you. Dotted line. And are we going to shade above or below? Above, because it's greater than. Okay, so go over here. On the y, you're going to put a dot at the 2. So put a dot there. And from there, you're going to go up 1 over 2, but it's negative. So it's up 1 over 2 like this, to the left. Or you can go down 1 over 2 to the right. Okay, since it's dotted line, sometimes I would just rather just do this, and these can be my dots. It's just easier. Or if you want to use your straight edge and connect it and make it all dotted, that's fine too. Just put little arrows on the end. And we're shading above. Okay, what that means is any point in this yellow part, I could pick out and plug it here and here, and it would make this whole statement true. But if I pick one off of that line, it's not going to work. It will not be true, because it's not including the line. Everybody kind of understand how I'm doing that? The biggest challenge is switching it to y equals. Okay, number 3. How about, let's see which ones I got here. Okay, 2x minus 3y is greater than 6. 2x minus 3y is greater than 6. Now what's the goal? How do I want my inequality to look? I want it to look like y equals mx plus b. So I need to get y all by itself. So start by moving this over here. If I want to move 2x to the other side, it's positive right now. I need to subtract it. So we're going to subtract 2x from this side, subtract 2x from this side. Here they cancel, but over here it doesn't really have anything to go with it. So it's going to be negative 3y is greater than, I'm going to put negative 2x in front, plus 6 in back. Why would I do that? I mean, what's the point? Why wouldn't I just put 6 minus 2x? Because I want it in y equals mx, so I want the mx first, plus the b second. Okay, so if I know I have to have it in that order, I might as well do it now. Alright, last thing I need to fix is this negative 3. So we're going to divide by a negative 3. Here, here, and here, because you can't leave anybody out. Whatever you do to one side, you have to do the other side, and you have to do it to everyone. This becomes plain y. I divided by a negative. So my rule, my exception to the rule still stands. So we're going to switch this arrow this way now. Negative 2 over negative 3 becomes positive 2 over positive 3. And then 6 over negative 3 becomes negative 2. So what's my M? And what's my B? Let me go ahead and box that in so you guys can see it. Should have done that. Okay, M is 2/3. Good. B is negative 2. Is this going to be dotted or solid? It's dotted. So it's a dotted line. Am I going to shade above or below? It's less than now because we divided by negative. That's below. Okay, so you know those two things. So go over here on negative 2, put a dot. For slope, you're going to go up 2 over 3 and it's positive, so up 2 over 3. Put a dot. Up 2 over 3. 2 over 3. I can go back over here and go down 2 over 3. Just like that. Put arrows on the end. Am I shading above or below that line? So it's below. Which means any point in that yellow area would work unless it's on the line. And if it's on the line, it's not going to work because it's a dotted line. That's what it tells you. Your answer is your graph. None of this over here is really your answer. Your answer is your graph. Okay, I think we'll just do these last two and not use that last graph. Okay, so what about x minus 3y is greater than or equal to negative 6? X minus 3y is greater than or equal to negative 6. So write that down. My goal is to get it in y equals mx plus b. I've got to move everything that's over here by the y away. It's got to go to the other side. So the first thing I'm going to move is this x. And it really doesn't have anything to go with it over there. So that cancels here. I get negative 3y is greater than, what's this going to look like? Negative x minus 6. What's technically in front of that x that we don't write? Technically that's a 1. You're going to need to know that here in a minute whenever you look at your slope. So go ahead and put a 1 there. I don't care. It's going to help you. So put a 1 there. What do I need to do next? Yes, divide by negative 3, but divide everything by negative 3. You notice every one of these slopes is turned into a fraction, and that's okay. For the one time in your life in math, fractions are perfect. That's what you want. So here I get y. I divided by negative, so we've got to switch the arrow. Negative 1 over negative 3 is a positive 1/3 x. Negative 6 over negative 3 is a positive 2. So m is 1/3. B is 2. Oh, I forgot my little line underneath there. Is this dotted or solid? Yeah, this one's solid. So solid line above or below? Below. Very good. So it crosses up the 2. Goes up 1 over 3. So it's solid line, so it looks like this. And you're going to shade below. So this means any point in the yellow or on the line can plug in and work. last one is one that's going to be kind of weird. X less than or equal to -4. There's really nothing to solve on this one. There's not even a y. But do you remember what I told you? If it only had an x in the equation, what did you know about the line? It only touched the x, remember? So you know that this line is going to be a vertical line somewhere. It's going to cross at the -4 on the x. So 1, 2, 3, 4. And is it dotted or solid? It's a solid line. So we're going to draw a solid line straight up and down like this. Okay, here's the trick though. Can I shade above or below that? Not really. It goes up forever. It goes down forever. So since it's the x, I need to shade less than. Less than on the x is to the left. Okay, less than on the x is to the left. What would it be if I had y is greater than 3? And it didn't have an x in it at all? If it just has a y, it just touches the y. So that would be like up here and it'd be horizontal. And if it was greater than, it would be above. So it'd be horizontal like that and shaded above. Basically, that's all the inequalities. We're just going to practice them now. So get your assignment out. Let me kind of walk you through a couple of those and we'll go from there.